from last 2 weeks I didn't post any videos. In the last video, I think we have discussed conformations of ethane. So many of you have approached through emails asking me to discuss organic chemistry, class 11 organic chemistry. From today onwards, every day I'll post one video by choosing some topics in organic chemistry, class 11 organic chemistry, so that we can cover the whatever the important topics are there in your class 11 organic chemistry. We'll cover those topics. This is for your board exams, intermediate exams, and for your class 11s, those who are preparing for CBSE boards and all. Okay, so today in this video we are going to discuss about the geometrical isomerism. So here in the last video we have discussed conformations of ethane, no? So here today we'll discuss geometrical isomerism or geometrical isomers. What are geometrical isomers? Here geometrical isomers, if two isomers are there, we call them as geometrical isomers, or the phenomenon is known as geometrical isomerism. This is otherwise called as cis-trans isomerism. Geometrical isomerism, other name of geometrical isomerism is cis-trans isomerism. So here what is cis-trans isomerism or the geometrical isomerism? So here the first condition to exhibit the geometrical isomerism is, here the molecule or the compound should contain a double bond. Okay. What is the first condition or the requirement to exhibit the geometrical isomerism? If you are given with any compound or a molecule and asked you to whether it exhibits geometrical isomerism or not, first you will have to look for the double bond. If that is the first condition to exhibit the geometrical isomerism. Now here around the double bond, if you observe the conformations of ethane, there is a continuous rotation around the carbon-carbon single bond, and n number of conformations are possible for ethane, I told you. So here, but geometrical isomerism, in the geometrical isomerism, here double bond, there is no such rotation around the carbon-carbon double bond. In the case of pi bond, double bond means one sigma bond and one pi bond, no? Double bond means one sigma bond and one pi bond, no? So here around the carbon-carbon double bond, here there is a restricted rotation. Rotation around the carbon-carbon double bond is restricted. So here only two isomers possible. For example, let us get into the topic. What is the geometrical isomerism? For example, it is the carbon-carbon doubly bonded compound, and it contains two groups, X and X, two similar groups or atoms, whatever it may be, and Y and Y. These two are the X and Y, two different atoms attached to each one carbon. These two carbons, between these two carbons there is a double bond. You just assume. So here now if this around this carbon-carbon double bond, if two similar groups, X and X are two similar groups, no? If two similar groups are oriented same side of the double bond, same groups oriented same side of the double bond, same groups or atoms present at the same side of the double bonds. Here they lie on the same side of each carbon, no? So same groups, same side, we call such isomer as cis isomer. Cis isomer. What is the first condition to exhibit geometrical isomerism? It should contain a double bond, because around here around the double bond there is a restricted rotation. So here, if these are oriented, if the two atoms are oriented around the carbon-carbon double bond on the same side, we call that isomer as a cis isomers. Or otherwise, if these two atoms, same atoms or the groups, present opposite side of a double bond, lie on opposite side of a double bond, we call this as a trans isomer. That's it. This is the geometrical isomerism. Okay. Geometrical isomerism, first condition, the molecule should contain a double bond. So here two types of isomerism, geometrical isomerism, otherwise called as cis-trans isomerism. Why here? Around the carbon, for example, let us take this, around the carbon, I have taken XX. You can take A and A, similar atoms. B and B, similar atoms. Two similar atoms attached to the two carbon atoms. Whatever it may be, if the same atoms present, same atoms are the groups present, same side of the double bond, we call that isomer as a cis isomer. If you look at here, this is the carbon atom, between these two carbon atoms there is a double bond, and here X present this side and X present this side. Same atoms, opposite side. The orientation of the atoms or the groups present opposite side of the double bond, it is the trans isomer. So this type of isomerism which arises due to the difference in the spatial arrangement of the atoms, because here if two atoms or the groups lie on the same side of a double bond, we call that isomerism as a isomer as a cis isomers. If the same atoms or the groups present opposite side of the double bond, we call this as a trans isomer, and this phenomenon is known as geometrical isomerism or cis-trans isomerism. So because of the difference in the orientation, these two isomers differ in melting point, boiling points, melting point and boiling points, solubility, and the whole important point, dipole moment. They differ in dipole moment also. They exhibit these two isomer, because of this different orientation, they differ in, they too. This is the second point you can write if you are asked to write the geometrical isomerism. Here this is trans isomer, they differ in the melting point, boiling point, solubility and the dipole moments. Okay, now we'll see some examples. Example is but2ene. Write the geometrical isomers for but2ene. This may ask for ask as a short answer also. So here but means how many carbon atoms? 1, 2, 3, 4. But means 4. Meth 1. If number of carbon atoms 2. Eth 3. Prop 4. But 5. Pent. You know that, no? So here but means, otherwise we'll make a separate video on the IUPAC nomenclature also, don't worry. So here but means 4 and here 1, 2, here it is 2ene. So here carbon valency 4, to satisfy the valency of the each carbon you just place hydrogens, 3 hydrogens, 3 plus 1, 4 bonds. Around this carbon atom, 1, 2, 3 bonds. So valency 3. So here you place 1 hydrogen, so that this carbon valency will become 4. And here around this carbon atom, 1, 2, 3, and remaining 4th valency is you place, for the 4th valency you place hydrogen, and here 3 hydrogens. So this is the way of writing structure. So but2ene, so 1, 2, 3, 4. 4 carbon atoms but, at the second position double bond 2, as the double bond the name ends with ene. It is but2ene. Okay, that is now here write the geometrical isomers. Here double bond is there. So here C, double bond C. Here note one point that every double bonded alkene, every alkene will not exhibit geometrical isomerism. Just note that point. Here for the molecule to exhibit geometrical isomerism, here it should contain a double bond, but every double bonded compound will not exhibit geometrical isomerism. Note that point. So here I'll clear that point also. Okay, don't worry. So here it is same atoms, you write cis-trans isomers. So same atoms are the groups present on the same side of the double bond. So it is the cis isomer of cis-trans but2ene. cis isomers of but2ene. And you write the trans isomer, carbon-carbon double bond. Here these two are the hydrogens. Just elaborated the structure and I have written and the same atoms, same side, lie on the same side, either below the double bond or above the double bond you can write. And if the same atoms or the groups present opposite side of the double bond, we call it as trans. That's it. Okay. This is the geometrical isomers. These are the geometrical isomers of but2ene. Okay. So if you observe how they vary, I want to discuss one small point, how they vary in the dipole moment. So here the dipole moment of the trans isomer is considered as 0, but here dipole moment of the cis isomer is not equal to 0. It is around 0.33 debye. Debye, it is an unit for dipole moment. It is debye. Okay, so here if you observe, what is the hybridization of this carbon? What is the hybridization? How to calculate hybridization? Just around this, how many sigma bonds are there? One sigma bond, second sigma bond, one pi bond, double bond means one pi bond and one sigma bond. Three sigma bonds, 3 means sp2 hybridization, and this carbon is sp2 hybridized carbon. And now you look at this carbon atom. So this is here 3 hydrogen atoms. So here I will elaborate this CH3 and write here. This is the CH3. This CH3. 1, 2, 3, 4. All are sigma bonds. 4 sigma bonds. 4 sigma bonds means this methyl. This is sp3 hybridized. sp3 hybridized. So here in the sp2 hybridization, what is the percentage of S character? So here 1 plus 2, 2 atoms are there. 2 divided by 100, which is equal to 33.3. If you observe this, 4 by 100, 25% of S character. So here more S character, you remember this one, more S character, more will be the electronegativity of that particular carbon. So here if you observe, what I want to tell you is, here the electronegativity of this carbon is more. Electronegativity of this carbon is more when compared to this one. I'll clear this one. Here just 3 atoms, no? 3 divided by 100 it is. 3 divided by 100, 33.3% S character. 4 atoms, sp3 hybridization, 4 divided by 100, 25% S character. More S character, more will be the electronegativity. So I'll clear this one first. So here it is the sp2 hybridized carbon and it is the sp3 hybridized carbon. Okay, now here what is the electronegativity of this carbon is more when compared to this one. What is electronegativity? Capacity of acceptance of bond pair of electrons towards itself. So here this electron, this carbon pulls the bond pair of electrons towards itself. Similarly, this pulls the bond pair of electrons towards itself. So here what is the orientation? Here this will be the orientation like this. So same side orientation, dipole moment is not equal to 0. But here if you observe, here from electronegativity like this, opposite side, resultant dipole moment will get cancelled. Because of this reason, we'll discuss in detail what is the dipole moment and what are the factors affecting dipole moment. But here for the trans isomer, if you are asked with discuss the dipole moments of cis and trans isomers in your board exams especially, So here cis isomer, the dipole moment is not equal to 0. For the trans isomer, dipole moment is 0. The reason is here, this is the sp2 hybridized carbon and it is the sp3 hybridized carbon. Percentage of s character is directly proportional to electronegativity. So this carbon is more electronegative carbon. Being more electronegative, it pulls the electrons towards itself. So because of this, there develops a partial negative charge. Here this carbon is pulling electron pairs towards itself, no, and this will get a partial positive charge, so which leads to the development of partial charges, polarity, which leads to the dipole moment. Here this dipole orientation, here resultant, there will be resultant dipole moment because the movement of electrons will be like this to the same side, but here the resultant dipole moment get cancelled as they are operating in opposite direction. So for the trans isomer, the resultant dipole moment is 0. For the cis isomer, the dipole moment is not equal to 0. This is the example. You can write to discuss if you are given with a short answer, 4 marks question. So if you write this but 2 in, that will be enough by explaining the dipole moment and the properties. Okay. Now we'll discuss in-text questions. Some two in-text questions are there. These are your in-text questions which will be useful for your board exams. Okay. So here the first question is write this is the question for this one is you can write the cis-trans isomers for the following compounds. Okay. Write the cis-trans isomers for the following compounds. So here he is asking you to write the cis-trans isomers or the geometrical isomers. So here C double bond C. First you write the double bond between the 2 carbon atoms, no? So what are the atoms present? H and Cl. These two are the atoms present around the carbon double bond. So first I have written carbon double bond. So cis means same atoms, same side. So remaining like this. And the trans isomer, you just reverse these two. C double bond C and here hydrogen chlorine. Reverse these two. Okay. So Cl hydrogen. Same atoms, opposite side. It is the trans isomer. That's it. And you write this one here. Just pause your video and try to write the geometrical isomers for the second one. Okay. So here first carbon atom, first place carbon between these two double bond. Okay. Now CH3 group is there, and here C2H5 is there, So same groups to write the cis isomers, same groups, same side. Whether you write below the double bond or above the double bond, that is your wish. So I will write here. So first double bond C. So it is CH3 and the remaining C2H5. Same atoms, same side. It is cis isomer. You reverse this one or this one, whatever it may be. C double bond C, CH3, C2H5. Here is your CH3, C2H5. You just reverse 1 carbon atom groups. Trans isomer. So write, the question is here. Write the cis-trans isomers for the following compounds. These are your in-text questions which will be useful for your board exams, intermediate exams. Okay. And also for the CBSE boards also. Okay. These two are the questions. Now, here you write the second question. Here, the question for this is, which of the following compounds will exhibit geometrical isomerism? I told you, no, one point here. To exhibit the geometrical isomerism, it should contain a double bond, but all double bonded compounds will not exhibit geometrical isomerism. To explain that point, here I have taken these examples. These are your in-text questions only. Okay. So, which of the following will exhibit geometrical isomerism? Okay. Now, I'll clear this one. One double bond you write. Carbon, double bond. So, here what is the group present here? It is hydrogen. And hydrogen and C2H5 to this carbon atom. So hydrogen, C2H5. Here two methyl groups are there. CH3, CH3. Here same atoms, same side means same atom should not be attached to one carbon atom. Same atoms attached to the two carbon atoms. Between the two carbon atoms there should be a double bond. So here there is no geometrical isomerism exhibited by this first one. Clear this point? Although double bond is there, two same atoms are there, no geometrical isomerism. Same atoms, same side, between two carbon atoms and among the two carbon atoms and between those two carbon atoms there should be a double bond. And you look at this question also, then that this will be very clear. See, double bond, see, two hydrogens, here one hydrogen, here one hydrogen, two BRs, one BR here, one BR here. Just think once. Is it exhibit geometrical isomerism? No. Same atoms, same side means not like this. If it exhibits geometrical isomerism, this exhibits geometrical isomerism. It is the cis isomer. Clear? So the second one also will not exhibit geometrical isomerism. Now, look at the third one. You look for the two carbon atoms, two hydrogens, okay, two hydrogens for two carbons, okay. So CH3, C6, H5. Will it exhibit geometrical isomerism? Yes, because same atoms present, same side. Cis, and you can write the transform also by flipping this. This is the transform. CH3 here, hydrogen here, CH3 here, and it is C6H5 hydrogen. Same atoms, opposite side. This is cis and it is trans isomers. So this third one exhibits geometrical isomerism. Now this fourth one, what about the fourth one? About the fourth one, here C double bond C, hydrogen and Cl, H, Cl, CH3, CH3. As this exhibits geometrical isomerism, this is thesis form and you write the transform. Clear? Okay, super clear. This is about geometrical isomerism. Tomorrow I will discuss what is Markovnikov's and anti-Markovnikov's role, or what is Ekarash effect and all. Okay. Till then, bye.